Computer science videos here today to show you guys in this tutorial, which is still part of part 1 overview, chapter 1 introduction, computer system operation, which is in computer systems organization, before we can explore the details of how computer systems operate. We need all the general knowledge, the background information of the structure of a computer system. And so, in this section, we will look at several parts of the structure. So we can now move on to the computer system operation. We can bring in the diagram of a modern computer system. A modern computer system. The diagram will be on screen. So we need a box for the memory, a couple of more boxes, so this is the memory, this is CPU, disk controller, USB controller, graphics, adapter, and then we can write this down before moving on. Disks, a mouse, a keyboard, a printer. These are all the peripherals. Last but not least, the monitor. And so, a modern general purpose computer system consists of one or more CPUs and a number of device controllers connected through a common bus that provides access to shared memory. Each device controller is in charge of a specific type of device, for example, disk drives, audio devices, or video displays, which we have on screen here. Video displays, disk drives. The CPU and device controllers can execute in parallel, competing for memory cycles. To ensure orderly access to the shared memory, a memory controller synchronizes access to the memory For a computer to start running, for instance, when powered on or rebooted, it needs to have an initial program to run. And this initial program or bootstrap program tends to be very simple. Typically, it is stored within the computer hardware. So, in read-only memory such as ROM, or electronically erasable programmable read-only memory, which is EEPROM, known by the general term file or firmware. It initializes all aspects of the system, the CPU register, or from CPU registers to device controllers to memory contents. The bootstrap program must know how to load the OS and start executing the system to then accomplish all the tasks. The bootstrap program must locate the OS kernel and load in memory. Once the kernel is loaded and executing, it can start providing services to the system and the users. Some services are provided outside of the kernel by system programs that are loaded into memory at boot time to become system processes or system daemons that run the entire time by kernel, which is running on Unix. The first system process is init and starts many other daemons. Only this phase is complete, the system is fully booted, and the system waits for some event to occur. The occurrence of an event is usually signaled by an interrupt from either the hardware or the software. The hardware triggers an interrupt at any time by sending a signal to the CPU, usually by the way of the system bus. Software may trigger an interrupt by executing a special operation called a system call, also called a monitor call. And so in this tutorial and video, we looked at a modern computer system, drew the diagram, explained what happens on a computer system through the computer system operation for the computer system organization. That's it for this video. I'll see you guys on my next tutorial, next video. Thanks for now.